We're graphing rational functions, and we're going to start with the parent function, y equals 1 over x. I've put it in the calculator so you can see what we're headed for. When we're graphing rational functions, we look for 4 attributes. So let's start with the vertical asymptote. An asymptote is a line that the graph is not going to touch. If I plug a 0 in for this x, I know that that's going to be undefined. So x can never be equal to 0 in this equation. So x equals 0 is my vertical asymptote. The next thing I'm going to do is look for the horizontal asymptote. I can see that no matter what value I put in here for x, y will never be equal to 0. So I'm going to graph that line at y equals 0. The next thing we're looking for are the zeros, or the x-intercept. Well, I already drew a line saying that it can't equal the anything on the x-axis, so I know that the zeros in this particular problem are going to be none. And now I'm going to look for the y-intercept, and I see it's going to be none also because I already put an asymptote there on the y-axis. So let's see what points we do have. And I'm going to go ahead and use the table in my calculator for now. If I plug 1 in for x, y equals 1. If I plug in 2 for x, y is going to be 1/2. Now I'll go ahead and put another number here. If x is 1/2, y is 2. So there's my branch there. I can see that as positive x gets larger and larger, this fraction is going to get smaller and smaller, but it's never going to equal 0. Let's do the other side. When x is -1, y is -1. When x is -2, y is -1/2. When x is -1/2, y will be -2. There's my other branch. As negative x gets smaller and smaller, this fraction is going to get smaller and smaller, but it is never going to touch 0. The domain, all real numbers except 0, and the range, all real numbers except 0. On this next problem, you find these same 4 attributes. Then come back and check your answer. See if you got it right. Let's try another kind. This is y equals 5 over x minus 1. Follow the same steps. We're going to find the vertical asymptote. So remember, I want to know what is going to make the denominator equal to 0. So solve x minus 1 equals 0. So x is a positive 1. There's my vertical asymptote. And now my horizontal asymptote. No matter what number I plug in here for x, y is never going to equal 0. So there is my horizontal asymptote at y equals 0. I'm going to give you an easy way to remember horizontal asymptote here in just a moment. My zeros, I can see that I'm not going to touch the x-axis, therefore I am going to have no zeros. And you can think, well, if I don't have an x in the numerator, then my zeros will be none. Now I'm going to look for the y-intercept. And remember, y-intercept is when x equals 0. I want to know what's y going to be. So let's think about it. If I plug a 0 into my equation, 5 divided by -1 is -5. So there's a point here at 0, 1, 2, 3, 4, 5. That's one of the points on my graph. Now I have to find other points so that I can draw the branches. I need a negative number for x so that I can draw the left side of my asymptote. If I plug a -1 into the equation, when x is -1, that's 5 divided by -2, which is -5/2, -2.5. So at -1, I have a point here at -2.5, and now I can just go ahead and draw my branch. Let's do the right side of the asymptote. So I'll start with a 2. and plug in 2 for x. That's going to give me 5 divided by 1 is 5, so I have a point at 2, 5. I'll go ahead and put in a 3 for x. 3 minus 1 is 2, so this is going to give me a 2.5. So at 3, I have a point on the y-axis at 2.5. The domain, all the real numbers except 1, which is the vertical asymptote. So if I write it in interval notation, this means that it goes up to 1 but does not include 1. Look at the range. The range does not include the 0, so our range is from negative infinity to 0 and 0 to infinity. Let's try another one. These are all the steps that we took in the parts of the equation that gave us each one of the attributes. For vertical asymptote, I used the denominator. I set the denominator equal to 0, solved it for x, and that gave me what the vertical asymptote is. The horizontal asymptote came from a over c, the coefficients of x. So if there's no x on the top, then we know that our horizontal asymptote is going to be 0. The zeros, or the x-intercept, came from ax plus b, came from the numerator. So I set the numerator equal to 0. That's going to give us our zeros. The last one is the y-intercept, which is b over d. Remember we said when x is 0, what's y going to be? If I plug in a 0 here, y is going to be whatever b over d is. So that is my y-intercept. Let's use that to do the next one. Vertical asymptote, the denominator, x minus 1 equals 0, therefore x equals 1. There's my vertical asymptote. Next, the horizontal asymptote, remember that comes from the coefficients of x, and there's an understood 1 right here. So the horizontal asymptote is 2 over 1, or just 2. There's the horizontal asymptote at y equals 2. Now I am looking for the zeros, or the x-intercepts. Remember I used the numerator for that. 2x minus 5 equals 0. Therefore x is equal to 2.5. So I'm going to have a point when x is 2.5, y is going to be equal to 0. When x is 2.5, y is equal to 0. So there's one of my points on my branch. The next thing I'm going to look at is the y-intercept. And remember we said the y-intercept is when x equals 0. If I were to plug a 0 into here, that would leave me with negative 5 over negative 1, which is a positive 5. So I have a point at 0, positive 5, and now I'm going to know that I'm going to have a branch over here. So I need some other points. I'm going to plug in first a negative number to give me another point over here. So I'll plug in a negative 1 into my original. 2 times negative 1 minus 5, that's negative 7. Negative 1 minus 1 is negative 2. So that's going to be a positive 3.5. So I have a point at negative 1, positive 3.5. Here's my branch. Now I'm going to do the right side. I need another point over here. How about if I use, let's choose one that's a little farther apart. How about 1, 2, 3? How about if I use a 4 for my x value? 2 times 4 is 8, minus 5 is 3, and 4 minus 1 is 3. 3 divided by 3 is 1, so I know I have a point at 2, 4, 1, and there's my branch there. The domain is going to be all the values except the 1. And the range is all the y values except the 2. Let's do one more. We have the vertical asymptote. Remember, once again, we're going to use the denominator. So x is 1. There is our vertical asymptote. And now our horizontal asymptote. Remember, we're going to use the coefficients of x. So y is going to be equal to 1. This is 1 over 1 is 1. So we've got the horizontal asymptote at y equals 1. Now we're looking for the zeros. We want to know where it's going to touch the x-axis, and so we can use the top part of the equation, set it equal to 0. X equals a negative 3. So we know that we have a point at negative 3, 0. 1, 2, 3, 0. There's one of our points. Now we're looking for the y-intercept, and remember the y-intercept is when x equals 0. If I plug a 0 into here, that's going to leave me with negative 3. So I know I have a point at 0, negative 3. So this is the left side of my graph. Now I need some positive points to give me the right side of my graph. Here's my t-chart. So how about if I use a 2? I'm going to plug a 2 into my equation. 2 plus 3 is 5, and 2 minus 1 is 1. That's going to give me 5. I have a point at 2, 1, 2, 3, 4, 5. And then how about if I plug a 3 there into my equation? 3 plus 3 is 6. And 3 minus 1 is 2. 6 divided by 2 is 3. So I have a point at 1, 2, 3, 1, 2, 3. And there's my other branch. The domain is all the values except for the 1. And the range, all the values except for the horizontal 1.